What is up, YouTube? This is Veer Math&More here, and today we're going to be going over a challenging problem for limits, which I find was slightly harder compared to the previous problems which I've gone over. And it's not as like it's harder because I'm going to explain a new concept, but it's just the fact that it can require a bit of a real understanding of how to manipulate limits such that we can find a concludable answer. So the limit is that, so we're going to want to find the limit as x approaches 0 for 4x squared divided by 1 minus cos 2x. And then, cos is your trig function. You just have this weird kind of irrational type of function, and you're going to want to just do it. So you want to write down your limit as your first step. And a common thing is, that I've taught and used before is multiplying by the conjugate on the denominator. So the denominator is 1 minus cos 2x. So the conjugate will just be 1 plus cos 2x. And remember, when you multiply with the conjugate, you have to do it on both the numerator and the denominator so that it is still equal to 1, and that means that the limit is the exact same. Now that you've multiplied by the conjugate, you can realize that the top is not really much. You just want to keep them as two separate factors, but this bottom can be rewritten as 1 minus cos squared 2x. And this is also known as sine squared 2x, because in trigonometry there is identity with the Pythagorean identity, which states that sine squared x plus cos squared x is equal to 1. You minus cos squared on both sides, and you get sine squared x is equal to 1 minus cos squared x. And that applies for any x, obviously. So, now that we know our denominator is actually sine squared 2x, we're going to want to write that down. So we have it written down right here that our limit is now 4x squared multiplied by 1 plus cos 2x, all divided by sine squared 2x. Now, we're going to do a simple procedure which I call separating or breaking the limit into two so that we can find our answer. So the way we're going to do it is that we're going to want to separate these two from this. And why? Well, let me explain first how we're going to write it down. So you're going to write your limit as x approaches 0, but now only for 4x squared divided by sine squared 2x. And then you're going to want to, because you're separating it, but there's still one coherent whole if you multiply them back together. You're going to want to write a multiplication sign for the other limit as x approaches 0 of 1 plus cos 2x. And that's the same thing as this. Now, why do we do this? Well, it's just that you have to realize 4x squared and sine squared 2x can be rewritten as 2x over sine 2x all squared, multiplied by limit x for 0, 1 plus cos 2x. Now, why does this matter? Because 2x over sine x, or sine 2x, sorry, is also 1 over sine 2x over 2x. And since we're looking at the limit as x approaches 0, there is a trigonometric limit which states that as x approaches 0 for a limit, of sine x over x, that will be equal to 1. So since we know that sine x over x as x approaches 0 is 1, then sine 2x over 2x will also just be 1. So this is also just 1 over 1, and 1 over 1 is just 1. So the point I'm trying to make here is that this whole thing can be written as 1. It's quite fascinating. And on the other side, where we're doing 1, the limit as x approaches 0 for 1 plus cos 2x. That is going cos 2x, or cos of 0, because we're plugging in x approaches 0, on the unit circle is going to be your cos, always your cos is equal to x, and x is going to be equal to 1 right here. Therefore, cos 0 is just 1. So 1 plus 1 is 2. And so 1 times 2 is just our final answer of 2. So I hope you guys liked how I used this challenging problem to show how you can multiply by the conjugate, break apart the limit, and rewrite obviously the limit using our trig identities, and then apply the trigonometric limit of sine x over x and cos x as limit of x approaches 0 to find our final answer of 2. So I hope you guys liked this video, and I'm gonna probably make a concept video on what limits are, and I've received some comments which are asking me to explain what are limits and how, what am I actually dealing with here. So it's going to be a quick video where I explain the concept of limits and maybe show off a few basic problems. But I hope you liked today's video, and that's going to be all. I love doing this problem, and I thought it would be great to show it off to you guys. So this is Math&More out. See ya.